Hey, let's go. Do you have any questions on those, what you did Friday, or the homework from Thursday night? Jordan?
I wasn't quite sure how to factor the polynomial.
Okay, so you want to look at like 17?
Yeah.
Okay. All right. Unless there's a different one. Okay, let's just do 17 then. All right, so for 17, it asked if this binomial was a factor of this polynomial. So what do we have to do to figure that out? What's it called?
Do the synthetic division.
Yeah, do the synthetic division part, right? Okay, so that's the polynomial you're given. All right, so remember, you like in your head, you set that equal to 0. What value of x makes x minus 5 equal to 0? 5, right? So we need to put the 5 in our little corner. Okay, so I got to put a 2 in for the x to the 4th, negative 12 for the cube, 6 for the x squared, 20 for the x, and then 0 for the constant. Okay, got to add the 0 on the end because that spot wasn't taken. All right, so don't forget that step. 5 times 2 is 10. When I add these, I get negative 2. 5 times negative 2 is negative 10. So when I add those, I get negative 4. 5 times negative 4 is negative 20. So when I add those, I get 0. 5 times 0 is 0. So when I add those, I get 0. So is x minus 5 a factor? Yes.
Yeah.
It is, right? Okay. So because the remainder is 0 makes it a factor. Yes. Okay. So this first part, okay, makes this smaller polynomial. It's reduced now. It started out as 2x to the 4th. Down here now it's 2x to the 3rd. This is x squared, and this is x. So that's what's in this second parenthesis. Is 2x cubed minus 2x squared minus 4x. And now we're supposed to factor completely. So we have to factor this trinomial here. So what's our first step in factoring? Look for a GCF. Well, what is the GCF? 2x, right? All right, when I divide 2x cubed by 2x, I get x squared. Negative 2x squared divided by 2x is negative x. And negative 4x divided by 2 is negative 2. Are there factors? That's a regular trinomial, right? It's an easy one because what's my a value for that trinomial? 1, right? So what are the factors of negative 2 that add up to negative 1? Somebody said it. Connors, say that again. 1 and negative 2, right. So x plus 1 and x minus 2, when I multiply the positive 1 and the negative 2, I get negative 2 for the c value. And when I add the negative 1 to the negative 2, I get the negative 1 for the b value. I like to put the GCF out front. That's why I moved it there, but it doesn't really matter where you put it. It's still a factor, though. So that's what you should have gotten for 17 once you're finished. Any others from the worksheet or the night before homework? One of the regular ones?
Yeah, I don't remember that.
Do you have a preference?
Not really.
Okay, let's look at 5, because a lot of you thought 5 was not factorable. So we got y to the 4th minus 13 y squared minus 48. Okay? So, is there GCF? No. Is it a difference of squares? No. Is it a sum or difference of cubes? No, because they only have how many terms? 2, right? Is the first and the third term positive perfect squares? No. So it's not a special trinomial, right? So it's a regular trinomial. So I'm looking for factors of negative 48 that add up to negative 13, which is negative 16 times positive 3. When you multiply those two, you'll get negative 48. When you add those two, you'll get the negative 13. Okay? So all you gotta do is put minus 16 and plus 3 here, right? The only thing that's different, instead of y squared, it's y to the 4th. So what do I put in front? Y squared, right? If it's y squared, we put y's in front. If it's y to the 4th, we put y squared in front. If it's y to the 6th, we put y cubed in front, right? Just take half of the exponent and put it in the front of each one. Okay? What is this first binomial? Yeah, that's a difference of squares.
That's correct. That's a difference in square.
So you can't do anything to y squared plus 3, but the difference of squares, we can go another step. What's the square root of y squared? Square root of 16. 4, then what?
Plus or minus?
Plus and minus. Good. All right? So Friday was just more practice of factoring, really. Anything else? Not for a while yet. We've got a couple more sections to go through before the next quiz. Probably next week sometime. Okay then. So today, this section 4-5, we're going to solve polynomial equations and find zeros of polynomial functions. Okay? That's the same thing, right? So we're going to do the first two today. I can explain how solutions of equations and zeros of functions are related, and I can solve polynomial equations. Tomorrow, we're going to go backwards. They're going to give us the solutions, or the zeros, is what we call them, and then we're going to have to find the problem, the polynomial. All right, so it says you have used the zero product property in factoring to solve quadratic equations. You can extend this technique to solve some higher degree polynomial equations, okay? So we've done this for the quadratic, the x squared stuff. Okay, now we're going to do the same thing for the x cubes, the x fourths, and so on. So what's the GCF?
2x.
2x, good.
2x.
So when I divide 2x cubed by 2x, I get x squared. When I divide negative 12x squared by 2x, I get negative 6x. And then 18x divided by 2x is 9. Now, this is 3 terms, a trinomial, so it's not a difference of squares or sum or difference of cubes. Is the first and the third term positive perfect squares? Yeah. They are, right? So I do that 1, 2, 3 test. Number 1 is the square root of the first term, which is x. Number 2 is the square root of the 9, which is 3. Number 3, I multiply those two answers. Is that answer half of the middle?
It is.
It is. So it's one of those special trinomials that we can factor as one binomial squared. What goes in the front and the back? Number 1's in the front, number 2's in the back. What sign between them?
Positive.
The negative. What's in front of the 6 is the sign you use in front of the B. All right? All right? So, The zero product property says if something times something is zero, either that is zero or this is zero, right? So what do I do to solve the left one? Divide by 2, right? What's x divided by 2? I'm sorry, 0 divided by 2. 0. That's one of my zeros. All right. Here, what do I do to get rid of that square root? Or square, sorry. Yeah, radical it, square root it, right? So, what's the square root of x minus 3 squared? Thanks, you guys. What's the square root of 0? 0. What symbol are we supposed to put in front? Yeah. Is that going to make a difference, though, when it's 0? No, it's not going to make a difference. But other time, it would make a difference, right? Then what do I do to get x by itself? Add 3. So what's 3 plus or minus 0? 3. No. It's still 3, right?
0.
It's not plus or minus 3, it's plus or minus 0, right?
I'm right here.
Okay, so there's our zeros. That's what we call. We solve that polynomial equation. Long time ago when we did, when we first did the practice of factoring.
It's likely I have that test.
No, I think you did okay.
You would.
All right, how about this one? What's the GCF? 5x, right? So 5x cubed divided by 5x is 1x squared, right, Nick? And negative 40x squared divided by 5x is negative 8x. And positive 80x divided by 5x is a positive, is that 16? Is that right?
Yeah, you're right.
Okay. So, again, I got 3 terms. Is the first and the third term positive perfect squares? Yeah. So let's try the 1, 2, 3 test again. What's the square root of x squared? Square root of 16. Multiply those. Is that half the middle? Yes. So I got 5x times number 1 in the front, minus again because it's whatever's in front of the 8. Number 2 in the back, squared. Okay. Again, if you forget to check to see if it's one of those special trinomials, you'll still get it because you'll say negative 4 times negative 4 is positive 16, right? And negative 4 plus negative 4 is negative 8. You'll just write x minus 4 twice, that's all. You'll still get the right answer. Okay, set them equal to 0, each factor, once you got it factored. And you solve those 2 equations. Okay, so you're going to divide by 5, you get x is 0 again. And here you're going to take the square root of both sides first, and you'll get x minus 4 equals plus or minus 0 again. So you're going to add 4. So there's our 2 solutions, our 2, sometimes they call them roots, our 2 zeros. Okay? So solutions, roots, zeros all mean the same thing. Depends if it's in function form or equation form, how they ask the answer. Questions on those? So you guys basically done this before, but we just did it for quadratics, the x squared ones, right, Spencer? All right. Then you need to start paying more attention and then doing more homework. Then you'll know. All right. So in example 1, the first one, x minus 3 appears more than once. How many times does it really appear? What was it? Twice, right? So this creates a repeated solution of x equals 3. All right? It says, note that the graph of the related function touches the x-axis but does not cross the x-axis. So let's look at the graph of that. Let's go back to that problem. We're talking about example 1 here. So I'm gonna put this 2x cubed minus 12x squared plus 18x in my calculator. And look at the graph. All right? You guys need to quit giggling on the side and in the back and pay attention. Okay, so there's the picture of the graph, okay? And if you look at where the graph crosses or touches the x-axis, those are the solutions to that problem, okay? And if we go back to this is 0, and that's 3, where those happen. So again, we got 0 and 3, right? So a way to solve these is to plug them into your calculator and see where the graph crosses or touches the x-axis. Okay? All right? So it says the repeated 0, x equals 3, it says the graph touches the x-axis but does not cross the x-axis. I call that bounces off the x-axis. So if it bounces off, it's raised to an even power. If you look at our factored form of that, what was our exponent? Is that an even or an odd number? Even. 2 is an even number, right? So if you have to graph, in your mind, you should know that it's going to hit and bounce off at 2. Okay? Because it was even. If it's an odd exponent, raised to an odd power, the graph of f crosses. It'll go through it. Okay? Even power, it's going to bounce off like this one, because this worked. We call that multiplicity. Now, I think later on they'll have us tell the multiplicity, but right now they haven't talked about that, so I'm not going to get into that. But that's what this is talking about when it's talking about multiple zeros or a repeated solution. Okay? If it works twice or 4 times or 6 times, it's going to bounce off. All right? If it works 1, 3, 5, 7, 9 times, it's going to actually cross through to the other side. Okay? So it says find the zeros, then sketch the graph. Okay, so we're going to find the zeros by factoring. What's the GCF?
2.
Well, I'm going to, since that's negative there, I'm going to make it -2.
-2.
All right, so x to the 4th minus 8x squared plus 16, right? All right, so it's got 3 terms, so it's not a difference of squares or some are difference of cubes. Is the first and the third term both positive perfect squares? Yeah. So does my 1, 2, 3 test work? It does. What's the square root of this? First one. X squared, right? What's the square root of the 16? 4. Multiply those. Is 4x squared half of -8x squared? Yeah. So this is going to be -2. Right, and we're setting it equal to 0 to solve it, right? To find the zeros, we set it equal to 0. So number 1 goes in the front. Number 2 goes in the back. What's in front of the 8? Minus. Well, what is x squared minus 4? That's a difference of squares, right? So I have to finish that What's the square root of x squared?
X.
The square root of 4 minus 2 and plus, I heard. But since there was 2 of them, there's going to be 2 of those, right? Okay. So what's making this 0? What value of x makes that 0?
Positive 2.
Right. You guys with me on that? What makes this one 0? Negative 2. Do I have to go through the work?
No.
Okay. So if this is negative 2, and this is positive 2, okay, and it's an even exponent, what happens here at these 2 points? Does the graph go through them or bounce off them?
Bounce off.
Bounces off of them, right? Okay? So,
Is that because it's even?
because it's even, yeah. All right? The exponents are even. So let's go and put that in. Let's clear that out. So we got, here's your negative sign down here at the bottom under the 3. Don't forget about that. And I'm putting in the original problem. And then I'm going to hit graph. All right, so did it do what we thought was going to happen?
Yes.
Yeah,
Bounce.
it bounced off, right? So, you know, a quick sketch of this. It's going to come up and hit, and it's going to go down through here really far and come up. What is that? Yeah, it's an M, but you guys should be able to tell me
Vertex.
what that y-intercept is by looking at the problem.
It would be -8.
No?
2 steps.
-3.
Yeah, remember,
Oh.
that's the y-intercept, right? So this point down here, this green point, is 0, -32. Okay, I know it's not exact the right spot, looking at those, unless I went
Go by 4.
forward,
What
yeah.
was the correct answer to what is this?
Okay, so
Because you said M, what's the right
it
answer?
said find the zeros, then sketch a graph of the function. All right, so the zeros
M.
are 2 and -2.
We just said M.
Yeah, I said what the y-intercept was. You guys said M because it looks like M. Okay, which is right. It does look like that. The x to the 4th ones usually look like M's or W's. Okay. All right. Questions on that? All right. Let's look at this one. Same thing. It says find the zeros and then graph it. Okay. So take out the x for the GCF. What are the factors of -6 that add up to +1?
2, maybe 3, -2.
+3,
Yeah.
-2, right?
Let's go.
So what makes x equal to 0? This x. What makes it equal to 0?
If it were 0.
Yeah, if it was 0.
Oh.
What makes this equal to 0?
-3.
-3. What makes this equal to 0? 2.
+2.
We good on that?
Yeah.
So our graph's going to cross here, here, and there when we sketch it. All right? It's also going to start down here. It's probably going to go up, come down, and back up. It's going to look like this. Okay? Watch. Again.
Just like we predicted.
Right? Just like we predicted, right? Okay? So that's what we thought it was going to look like. And it does. Okay? So again, you can use your calculator to find those to help you if you want. You could go second graph for the table, and we can look for these zeros. Okay? We're looking, the zeros are when the y is 0, because you're on the x-axis then. There, here at -3, here at 0, 0, and here at 2, 0. Okay? The calculator can help you through this stuff. Is that making sense? Okay. All right. One more thing here. It says this is the rational root theorem. Again, we don't usually use this very much because our calculator is finding the zeros for us, okay? But if you didn't have a graphing calculator, you would have to use the rational root theorem to figure out these zeros, okay? So here's an example of a problem right here. And it says the solutions are these three fractions. All right? -5/2, -3/4, and 7/8 are the answers. Those are the zeros. You know, where it crosses the x-axis if we were to graph it for that problem. It says, notice the numerators, 5, 3, and 7 of the zeros are factors of this. All right? So those are for the numerators. 5, 3, and 7 all go into -105. Okay? Or it's -5, -3, and +7. Okay? The denominators, 2, 4, and 8 are factors of the 64. Okay? If I wrote all the factors of 64, you got 1, 2, 4, 8, 16, 32, 64, right? So it says these observations are generalized by the rational root theorem. Okay? So you can write those factors as fractions, p over q. All right, so the p goes with the constant term, and the q goes with the leading coefficient, those factors. So if you didn't have the graphing calculator like we had, you would have to figure out all those fractions that could be possible zeros using this rational root theorem. Okay? And the way you would test them is with synthetic division. And how would you know if it was a 0? What would your remainder be when you do synthetic? It would be 0. Okay? So that's how I used to have to do it. I didn't have a graphing calculator in high school. So I had to use this rational root theorem, figure out all the factors of the constant term, all the factors of the leading coefficient, write all those fractions, and then start using synthetic division and look for zeros. Okay? You've got it a lot easier because you have the graphing calculator. Okay? So when you have a problem like this, okay, we're just about done. All right, just put it in your calculator. Okay? You listening to me?
Yeah.
Just put it in your calculator and look to see where it crosses your x-axis. Okay, how many am I expecting since it's a degree of 3? 3. Okay? So here's my 3 zeros. Here looks like -1, 1, 2, 3. That looks like a 4, and that looks like a 5. How can I check real quick? So make sure, go to the, oops, not the Weichels, but the table. All right? -1 worked, right? Let's go down and see if we can get 4 and 5 in there too. There's 4 and there's 5, yeah, so we can get all 3 of them on that table, okay? So if you just graph it and give me, label these for me, using your calculator, you're listening? Using your calculator, just sketch the graph and label those 3 zeros, that's fine with me. Okay? If you want to try to factor it, you can, but I don't know if that factor is very nice. I don't think it does. Okay? We don't have time to go forward to the last example, but that's okay. There's your homework.